Hello everyone, in this tutorial I want to show you how to use the VMD more efficiently by using the clipping plane tools that I want to discuss today to see what's going on in detail in your simulation domain before going further to do more advanced or detailed post-processing simulation. So let me open the VMD. Here I have the version 1.9.3. You can add your molecule file. So I have one file already ready here. I'll upload it into the VMD file, and I hope you all are familiar with the basics of the VMD, but I will try to make more tutorial on that as well. But in this specific tutorial, I want to talk about more advanced options of the VMD. So if you look at my simulation box, it contains, let me explain it a little bit for you. This simulation system contains water molecule, which is the 70 by 70 angstrom cubical domain of water molecule, and I have two small plate of the carbons. If you could see right in the middle, I don't want to change the size of the atoms in order to see them, right in the middle of the simulation domain. So if I increase the size of the molecule, let's say go to the graphic representations and change the drawing method to van der Waals, or you can, for example, go to the selection. That's okay, I think, just for all atoms. And if we increase the sphere scale to, for example, let's say 3, yes, okay, you will see that it's not clear anymore to see what's going on close to those two carbon walls that I have right in the middle of the simulation box. So here in this tutorial I will show you a nice feature of the VMD which enables you to go through your simulation box by defining a plane or surfaces that you can cut the simulation box with that. So if you go to the extension and under the visualization, you will see a clipping plane tool here, which is very useful. I found it very useful. And here it will give you options to define. It will give you options to define 6 different plane in any direction that you want. I mean, any direction. So you just should know what are the coordinates of your simulation box. So I have the X, Y, Z, and I mean a perfect Cartesian coordinate, but you may have some spherical coordinate or any kind of other coordinate system that you're working with. But you can define any surfaces as long as you know the normal vector of that surface. So I will show you how. So if you click on the render solid, okay, if you click on this 0, 1, 2, 3, 4, 5, overall 6 different planes. If you click on this 0, this one will get activated. And here you can define the normal value. Just be careful. For example, this is the X value. I will define 0, 0, and 1. So it should be in the Z direction. The normal vector is in the Z direction and the plane is X, Y plane. So if I active this plane, you will see in the Z direction I cut my simulation domain parallel to the Z direction. The beautiful part of this feature is you can change the depths of the cutting by just scrolling this tab here. you will see. This is a very nice feature, and you can look at what's going on, for example, at these steps. You can rotate your simulation and see how water molecule are. So in this simulation, I have the water molecule. So these red atoms are the oxygen atoms, and the white ones are the hydrogen atoms. So you can zoom in what's going on right in the middle of your simulation domain. Furthermore, you can define other surfaces. For example, let's define this plane in the perpendicular to the x direction. So I will define this one. The normal vector is the x vector, so I will define 1, 0 for y, and 0 for z. So this is yz plane, and this is activated by having this check mark in this small box. So again, you can see how things are working. See, I define another plane, and now I cut my simulation system to parallel to the YZ surface, and I can control the depths of that simply by just scrolling this toolbar here. This is a very nice feature, and you can define any kind of plane. For example, you can define here, instead of 1, 1, you can define something like that. As long as you know what is the normal vector of that plane. So it has a 45-degree angle this time, if you notice. This is a very nice feature that will enable you to look at the detail of your simulation. For example, in this case, I was looking for some vapor formation between these two hydrophobic surfaces. I could see if my simulation are correct. Then I can process it more in depth by writing a code or finding, for example, the diameter of that vapor or anything else. Appreciate your time. I hope you enjoyed this. I will try to put more tutorial on the VMD.